In this problem, I need to graph my function accurately, and I want to show any asymptotes with dashed lines. So in order to do this, I'm going to find my asymptotes. I'll start with vertical asymptotes, and I have one vertical asymptote because if I set the denominator of my fraction equal to 0, then I get x equals -4. So I can just take the square root of both sides, and I get x plus 4 equals 0, and then of course x must equal -4. So that's my vertical asymptote. I'll go ahead and graph that. Okay, so I graphed my vertical asymptote with a dashed line, and now I'll look to see if I have a horizontal or oblique asymptote. And in this case, I have a horizontal asymptote, because the degree of the denominator is more than the degree of the numerator. So that means that my horizontal asymptote normally would be y equals 0. Except in this case, we have a vertical shift. So since this graph is being shifted up 6 units, that shifts my horizontal asymptote up 6 units. And so my horizontal asymptote is y equals 6. So now I'll graph that. Okay. So now I've got my asymptotes in, and I can graph the function 1 over x squared, because really I just have 1 over x squared that's been shifted to the left 4 units and then up 6 units. That's really what's going on here, and then reflected about the x-axis. So I'm going to go ahead and graph a few points, and I can use the table in the calculator to find what these points are, but basically going to be about here. And very quickly you approach that horizontal asymptote. You just do your best, just don't cross that horizontal asymptote. And now I'm going to approach the vertical asymptote going the other way. And it almost becomes a vertical line at this point. Oops. There we go. And then I'll graph the other side. This is going to graph like so. And you can put this into your graphing calculator to see what the graph looks like precisely. But this is fairly accurate. And so I've got my asymptotes in there, and that's all I was asked for. So that's my final answer.